Let's build a stunning particle orbit animation using nothing but Flutter's built-in animation tools. If you've ever wanted to make your app feel alive with motion, this is a perfect visual to add to splash screens, dashboards, or loading overlays. Let's jump right in by creating a new Flutter project. In main.dart, we're setting up a basic material app and pointing home to orbit animation screen. Now let's move on to the orbit particles animation.dart file that will display the animation. We're going to use CustomPaint to render the particles frame by frame. Let's look at the Orbit Painter class. This is the heart of our custom drawing. It extends CustomPainter, which is a powerful class in Flutter that allows you to draw directly onto the canvas. Notice how Orbit Painter takes an animation of type double called animation in its constructor. This is crucial. We're passing our animation controller to this painter, and by calling super, constructor of the parent class, which is CustomPainter, and setting the repaint argument to animation, we're telling Flutter to repaint our CustomPainter every time the animation's value changes. This ensures our particles move smoothly. In short, the Orbit Painter constructor passes the animation to its parent CustomPainter's repaint argument, ensuring the painter redraws whenever the animation updates. Now let's break down the paint method. This is where the actual drawing happens. The canvas object is what we draw on, and size gives us the dimensions of the area we're painting within. We first calculate the center of our drawing area. Then we set up a paint object which defines how our particles will look, starting with a white color with 80% opacity. We've defined particle count as 100, meaning we'll have 100 little particles orbiting. And radius is set to half the width of our painting area. This will be the general size of our orbit. Now, here's the loop where the magic really happens. We iterate 100 times, once for each particle. Inside the loop, we calculate the angle for each particle. This is key to making them spread out around the circle and move. We take 2 into pi, a full circle in radians, divide it by the particle count to evenly space them out, and then add animation.value into 2 into pi. This animation.value is what makes them orbit. As the animation progresses from 0 to 1, the particles complete a full rotation. Next, we have a clever little line for orbit radius. Instead of all particles orbiting at the exact same distance, we're giving each particle its own slightly different orbit radius. This formula creates 5 different concentric orbits, making the animation look much more dynamic and interesting. The I modulo 5-part cycles through values 0 to 4, effectively creating these different rings. With the angle and orbit radius, we can then calculate the x and y coordinates for each particle using basic trigonometry. Center.dx plus orbit radius into cosine, angle, for the x-coordinate, and center.dy plus orbit radius into sine, angle, for the y-coordinate. Finally, canvas.drawCircle draws a small circle, with a radius of 2, at the calculated x-y position. Notice that we're dynamically setting the color of each particle using the getColor method right here. Let's peek at that getColor method for a second. It takes the index of the particle. We calculate a hue based on the index, making sure it cycles through 360 degrees. Then we convert that hue into an HSV color and then to a regular color. This gives us that beautiful rainbow effect, where each particle has a slightly different color from its neighbor. The shouldRepaint method simply returns true. This means that whenever the animation's value changes, we want to repaint everything to show the new positions of the particles. Alright, moving on to Orbit Particles Animation Widget. This is a stateful widget because it needs to manage the animation controller. Inside Orbit Animation Screen State, we mix in Single Ticker Provider State Mixin. This mixin is essential for providing the VSync property, which synchronizes our animation with the screen's refresh rate, preventing unnecessary redraws and ensuring smooth animation. In our initState method, we initialize our controller. We create an animation controller with VSync, this, and set its duration to 10 seconds. And critically, we call .repeat on it, which makes the animation loop continuously. In dispose, which is called when the widget is removed from the widget tree, we make sure to dispose the controller. This is super important for memory management, preventing memory leaks by releasing the resources held by the animation controller. Finally, in the build method of Orbit Animation Screen, we return a scaffold with a black background, giving a nice contrast to our colorful particles. Inside the body, we have a center widget and then our custom paint widget. We pass our Orbit Painter instance to its painter property, providing our controller as the animation. We also give our custom paint a fixed size of 300 by 300, which defines the area where our particles will orbit. And that's it. When you run this code, you'll see a captivating display of 100 colorful particles gracefully orbiting in concentric circles, endlessly repeating their dance. You can play around these values to tweak the animation according to your needs. It's a fantastic example of how Flutter's custom painting and animation capabilities can bring your UI to life. And there you have it, a gorgeous, math-driven particle orbit animation built entirely with Flutter. If you have any questions, leave them in the comments below. Thanks for watching and happy coding.